Hello, my name is Brian Toe, and this is my lab report for the Motion with Constant Velocity lab. Um, Within the lab, we observed the motion of an object, in this case a marker, as it rolled in a straight line with constant velocity. The experiment measured the position of the object over time and made comparisons between the observation data through tracker and the data from a Glowscript model's predicted positions. The predicted positions were made through Newton's second law of motion, which states that an object will stay in motion with constant speed and direction unless an unbalanced force acts on it, as given by the formula final velocity equals initial velocity plus F net divided by mass times delta t. If velocity is constant, then F net would be zero due to balanced forces. Thus, the final velocity and initial velocity are equal. This allows us to calculate the position through the formula final position equals initial position plus velocity times delta t, and this is with the mass being constant. Though there are problems with F net being zero, as it is difficult to consider all forces acting on the marker being rolled in the experiment, including friction force, just as it rolls along the table, and weight force if the table is not perfectly straight. Different forces like this are difficult to tally up and account for altogether, or even break down into counteracting each other for F net being zero. This could lead to problems later on in the experiment. This data was obtained with tracker to form this graph and these different position values. And through this, the initial velocity was calculated to be 0.408 meters per second, and through video analysis and tracker's own software. The initial velocity could be flawed in that it's not actually the constant velocity as shown by the rest of tracker's measured velocities throughout the object's movement. At the stage before, this could be due to friction causing the object to slow down, and that wasn't actually accounted for in the experiment. And the hand-selected tracker positions that were manually entered might not be completely accurate due to human error as well, which could cause compounding issues as the Glowscript's modeled positions are due to a recursive form. The actual and modeled positions are shown here, and there is a decent contrast between the actual and model positions as shown by this deviation. This could be due to the initial velocity being greater than the final and average velocities, and this led to an overestimation. The model did not account for friction or weight force or any things in were included in the observation of the actual object's motion. This was the output of the Glowscript run, and just to show here as well, this is the Glowscript modeled the movement of the marker as it just rolled in a positive y direction. If the y-axis were to flip in tracker, it would just cause the data itself to also flip up down, as y would just go in the negative direction, and it would just lead to the same position values but a different velocity technically due to the direction becoming inverse or opposite. In consideration of all the pushes and pulls, it is very difficult to consider all the forces acting on the rolling marker, And in terms of the F net equals 0 that we observed, it would be very challenging to break down each of the individual forces that are added together that counter each other to get this observed F net equals 0. It's a lot to consider different forces like we mentioned before, the force of friction acting against the marker as it rolls, the force of the weight on the marker if the tape was not perfectly flat, and adding up all of these together to make sure that they are